Hey guys! In this video I wanted to explain some of the basics of scale factor and what that is. So from an equation standpoint, a good way for you to think of scale factor is to think that scale factor is equal to new length over original length. That's the way it's going to work whenever you're dealing with figures in geometry, especially when they say they did a transformation or they did a scaled copy of something. The way you would find the scale factor is by taking the new length of the shape and the corresponding original length and dividing them. You can also leave your answer as a fraction, and you can also write it as a decimal. The other thing to be aware of is if you progress to other mathematics classes or physics classes, sometimes they'll call scale factor, they'll use the letter K to represent scale factor. I haven't gone through and looked exactly as to where that comes from, but I'm sure you could figure it out if you're curious. So what I mean by that, new length over original length, is let's say I have two triangles and they tell me that triangle A transforms and it becomes triangle B. Now, first of all, this transformation, for you to use scale factor, it would have to have happened in a similar proportion, meaning the scale, this is a scaled copy. All of the angles are still the same in my new figure. It's just that the lengths of the sides has increased, or sometimes decreased, by a specific factor. So if, let's say, this one had a side length of 2 and this one had a side length of 6, then you could say that that scale factor was 3. And I would take that by reading the directions. The hardest part is determining which one's the new and which one's the original. Because sometimes, they don't draw an arrow to show you this one became this one. You kind of have to read into the context of the question to figure out which one's the new one and which one's the original one. I like to remember that it's the new over the original by just thinking about, like, if you were going to paint a house, you would put the new paint on top of the original paint. And that's just how I remember the formula. So if I was going to find the scale factor, I would take the new length, which is 6, and divide it by the original length, which was 2, and that would give me a scale factor of 3. Now, sometimes your shape doesn't become an enlargement. It's actually a reduction. So we know that any scale factor that is greater than 1 is going to give us an enlargement. If our scale factor is less than 1, but not negative, because that wouldn't make sense, if it was between 0 and 1, then we know that our scale was actually a reduction. So let's say I had figure A, and it becomes figure B, and let's use these same numbers. Let's say 6 was this original side, and now this side changes to 2. So again, I physically have to write it out when I'm working out the problem. I have to write, oh, this is the new, this is the original. That's just how my brain works. I'll make a mistake or I'll get confused if I don't do that. So the scale factor is always going to equal your new shape divided by your original shape. Now, depending on your teacher or depending on the program you're working on, they might let you say 2 over 6 is the answer. Some teachers would make you reduce it to 1 over 3, and some people might even have you write it as a decimal, which would be 0.3 repeating. So those are the basics of scale factor and how it works. However, the trick that comes in, the way they throw you off your game in geometry, especially high school geometry, is they start talking about area. And I'm very clear when I wrote this example or this formula, length is what scale factor is based on. So you can use any length. It could be a single length. You could even compare the length of the perimeter to the length of this perimeter. That would also give you scale factor. But scale factor does not tell you directly how the area changes. So I created something, or I call it area factor, just so we have another name to call it by. So area factor is when we have figures that have been scaled, and the way we find the area factor is we take the scale factor and we square it. So the way that that would apply in a problem is, let's say I had this triangle, and let's call it triangle A, and this triangle, let's call it triangle B. And let's say they told us that the area of this triangle is 10, and let's say they tell us that the area of this triangle is 40, right? And we'll say this one scaled, they increased the scale, they made a scaled copy, and now this one has an area of 40 after the enlargement. And then they ask you, well, what's the scale factor? You can't just take the new area and divide it by the original area. If you did that, right, you would have the new area of 40 divided by the original area of 10, and that would give you 4. But the 4 is not the scale factor. The 4 is the area factor. In order to figure out what the scale factor is, you're going to have to take this area factor and square root it to get the scale factor. If you'd like to set up equations, maybe it would help you to write scale factor squared equals 4, and then in order to solve that, you could square root both sides. The square root cancels the squared, so you get the scale factor is equal to 2. Now this can work in the reverse. If they tell you the scale factor, give you an area, and then expect you to find the new scaled area. So let me try an example for that. So let's say they tell you this triangle here turns into this triangle, right? It got bigger. And they tell you that the scale factor that they used to enlarge it was a scale factor, let's just say the scale factor was 3. And they tell you that this triangle had an area of 10, like units squared, and then they want to know what the area of this one is. Well, the mistake that most students will make is, because they gave them the scale factor, they'll think, oh, I just get to multiply the 10 by the 3 and I'll get 30. But you have to remember, that only works with lengths. Scale factor can only work with things that are linear, such as the length of a side or the entire perimeter of a shape. If I said the perimeter was 10 and there was a scale factor of 3, the new perimeter would be 30. Because we're talking about area, what you would have to do is convert the scale factor to the area factor. So I could say that 10 times the scale factor squared will give me my new area. So that would be 10 times 9, and I would actually have a new area of 90 units squared. Now this is just a very quick run through of how scale factor and area factor work. There's also volume factor. So if you could kind of guess from the progression of things, the volume factor is actually the scale factor cubed. And then, to take, if you had the volume factor, you would have to cube root it to get back to the scale factor. So not a super in-depth video, but I wanted to do a quick run through just a very basic level, and I can make more videos if you have a specific question that you want to send me if you're still confused. But I hope this clears it up a little bit, and I hope you have a great day. See ya!